discuss fitting of the curve y is equal to ab to the power x. So earlier we discussed the fitting of the curve, that is a straight line. Then we discussed fitting of a parabolic curve, and now ab to the power x. Now the curve which is to be fitted is y is equal to ab to the power x. In order to solve this, we'll reduce it to a straight line, and we may use then the normal equations of the straight line. Take log on both the sides of this equation. So on taking log, we'll take log to the base 10. So if I do not write here to the base 10, it means that it is to the base 10. So on taking log, we have, and just I said, it is all to the base 10. Now what do? We substitute this as capital Y, and you may substitute this as capital A, and you may substitute this one as capital B. So in this way, this equation reduces to y is equal to A plus capital B, and here the variable x, small x, remains the same. In this way, it reduces to the equation of a straight line, and we know the normal equation of a straight line. What is the normal equation? Normal equation of a straight line is sigma capital Y, and if you remember, it is NA. We had discussed it in our previous lectures. And then capital B sigma x, multiply it with x and take summation on both the side. So this will be the normal equation for this particular ab to the power x to be fitted. Now let us move to the question number 1. Now in this question, we have to fit this curve y is equal to ab to the power x, and the data is given to be this. Let us see what all we need as a heading of the column. We need capital Y, which is obviously log y. We need multiplication of small x and capital Y, that is x and log y. Similarly, we need sigma x and sigma x square. Let us quickly make the heading of the column x, y, capital Y, which is log to the base 10y. And then we need x square and x small y. Let us see the values of x which is given. It is 2, 3, 4, 5 and 6. 2, 3, 4, 5 and 6. The corresponding value of y, let us write it. It is 8.3, 15.4, 33.1. Let us take the log. You may use your calculator. You have to find the log to the base 10. Right, so we found it to be this. Now we have to find x square. So it is 4, 9, 16, 25 and 36. Now we have to multiply small x and capital Y column. Let us multiply. Use your calculator and write the answer. Okay, so now I had written it. Now let us take the summation. If we take the summation, we'll get sigma x is equal to 20, which we need. Now sigma capital Y is equal to 7.5458. We'll find sigma x square, which is equal to 90. And now sigma x capital Y, which is coming out to be 33.1821. Now we have to put all the values in this normal equation. If you can see this equation, let us put all the values in this equation. I'm putting the values in the equation. So it is 7.5458 is equal to, let us see how many values are there. What is n? 1, 2, 3, 4 and 5. So I'm writing the value of n as 5 plus 20 b, because sigma x is 20, so I've written here 20. And now small x into capital Y is 33.1821 and it is 20a plus 90b, which is x square. So I've written here 90. So there are two equations and two unknowns. Solve the equations. You have the facility to solve the equation using your calculator also, or you may use the elimination method, or you may use the matrix method, whatever you remember or know. Let us solve this equation, and on solving these equations we'll get the value of unknown, that is capital A and capital B, and the values are coming out to be this. If you remember, students, our capital A was log A, log to the base 10A, and capital B was log to the base 10B. So that means that we found the value of log to the base 10A and we found the value of log to the base 10B. Obviously, in order to find the value of small a and small b, we need antilog. Okay, so small a is antilog of 0.3096. Again, you have to use your calculator to find the antilog of 0.2999. Use your calculator to find the value, and once you will use it, you will find the value of A and B as 2.04 and 1.995. Let us substitute this value to the curve which we want to fit. We wanted to fit this curve. We are putting the values in this curve, and the value is 2.04, 1.995 to the power x. So this is our required fit. We had fitted a b to the power x to this given curve in the question. The main crux here was to reduce this equation. If you remember, we had taken log to the base 10. If you still have any queries, please ask in the chat. Try to solve all the questions of this form.